So today we're going to talk about pH calculations. This is the last of the new information for Unit 10. So Monday we talked about just the pH scale and what that is, and it's how we measure how acidic or basic something is. So today we're going to talk about, well, how do we calculate pH? Because really pH, we say it's a measure of how acidic or basic something is, but really you don't measure pH, you actually have to calculate it, and you calculate it based on the hydrogen ion concentration. So when somebody says they're measuring pH, really what they're doing is they're measuring the hydrogen ion concentration and then using that to calculate the pH. But we don't really say that, that's too long. So we just say, oh, I'm measuring the pH. Okay. So after today, your test is already up for Friday. So that's what's on schedule for Friday is the Unit 10 test. It is already posted. So if you are ahead and you want to go ahead and do it today or tomorrow before Friday, that's completely fine. If you want to wait till Friday and do it during class time, that's fine too. But it is already up and posted for you guys to work on. Before we get into the lesson today, the other thing I wanted to mention is, so if I'm going to kind of collapse this unit. So if you go on y'all's Canvas right now, all y'all can see is Unit 9, Unit 10, and then you can see this module that's at the top. This is the new one. So this is for our review and final exam. And this is also serving as kind of the last chance for anybody that needs grade redemption. So the way this is set up, the very first page has a grade redemption contract. So if you are somebody who you failed one or more 6 weeks throughout this year, so that could be from first semester, it could be first, second, third 6 weeks, or it could be this semester, fourth 6 weeks, fifth 6 weeks, or maybe you haven't done all the stuff you needed to do for this 6 weeks, even though we're not done yet. Okay. So if you fall into one of those categories where you didn't pass one of the 6 weeks, and you can go back and check self-serve if you need to check, if you can't remember like which 6 weeks it was or anything like that, then you will fill out this Google form, and it just kind of goes over what exactly you're going to have to do. You put in your information, which 6 weeks you're having to make up, your parents' information, and then you'll type your name at the end, kind of like signing your contract, and you'll submit it. Once you've done that, how this is going to work is in this module, there is an assignment for each 6 weeks from first semester. So these have only been assigned to the people that need them. So if you can't see these where it says first 6, second, third 6 weeks, then that means that you don't need to do it. Okay. The ones from this semester, though, are assigned to everybody because even if you're not going to do it for redemption, it is still here for you to use to review for the final exam. Okay. So what you guys probably most need to work on is the stuff that's labeled fourth, fifth, and sixth 6 weeks, because this is all the stuff that's going to be covered on your final exam that we'll be taking in a couple weeks. Okay. So for 6 weeks, the kind of two things we covered: types of chemical reactions and balancing chemical equations. So there's kind of a review for each of those. For fifth 6 weeks, we had moles and gases. So there's a review for each of those. And for this current 6 weeks, we did solutions. And right now we're finishing up with acids and bases. So if you failed fourth or fifth 6 weeks and you would like to redeem your grade for that 6 weeks, what it says on the grade contract is, for example, if you needed to make up for 6 weeks, it says that if you do both of these review assignments for 4 6 weeks and submit them, and you make a 70 or higher on both of them, then that will be your redemption for 6 weeks. Okay. Same thing for fifth 6 weeks. If you do both of them that are labeled here for fifth 6 weeks and submit them, those two review modules or review assignments will replace your fifth 6 weeks grade for redemption if you make a 70 or higher. If you're behind and you haven't done stuff for this 6 weeks, like, so I know there's a lot of people who haven't done the solution stuff or the test yet. Okay. You can do, that in place of the assignments for solutions. And then if you've been keeping up with the acids and bases, then we still have our test on Friday. But if you haven't even been keeping up with that, then this is there as well for this current 6 weeks. For the first semester, there's only one assignment because they're kind of longer. It covers multiple topics. So there's one for first 6 weeks, one for second 6 weeks, one for third 6 weeks. Again, we don't have as many people that need to do those, so I just assigned those to the particular people. But these, since it's the review for the final exam, these got assigned to everybody. Okay. that's how that's going to work. So again, if you're going to do them for any of the makeup redemption, please, you have to make sure you fill out this contract. Okay. And so you'll submit it. If you don't know which 6 weeks you're making up, you can check self-serve. Okay. All right. Back to today's topic or today's lesson on calculating pH. So we're finishing up our last unit, unit 10, pH calculations. So I'm going to go down here. Essentially, we talked last time, as I mentioned, that pH is a measure of how acidic or basic something is. So in the labs, there's different ways we can measure it. There's a machine called a pH meter where you can dip this little probe into a solution and it's connected and it will read out the pH on the screen for you. There are also things called indicators that we kind of talked a little bit about last time. And those indicators are different chemicals that they are going to react differently in something that's acidic or something that's basic. And so they're going to turn different colors. So this one right here, these are little strips are soaked in what we call universal indicator. And so it turns all these different colors based on what the pH of something is. There are other ones, like we talked about litmus paper, that only turns like red if it's an acid or blue if it's a base. So there's like some that are less specific like that, but then there's some like this one that's more specific. Like there's several different shades, different colors to indicate about what the pH is. The best thing though is always going to be to use a pH meter because it's going to read out digitally and it'll tell you exactly what the pH is. So really though, as I said, we're not actually measuring the pH. We're measuring the concentration of hydrogen ions, and then pH is calculated from that. So this is the equation that you use to calculate pH. It's pretty straightforward. It's the negative, so you always have to put a negative sign in front, the negative logarithm of the concentration of hydrogen ions, because that's how the measure of something is acidic. And so in your calculator, the log, you want to look for the log button. So if you're using like a digital online one, or if you have your own scientific calculator at home, just look for a button like this that says log. That's usually what it looks like. And so one thing I want to point out is the pH scale is logarithmic. It uses this logarithmic calculation. So what that means is that if we increase or decrease the pH by a value of one integer, then that's going to change the concentration of hydrogen ions tenfold. That means times 10. So for example, if I have a pH of 3 and I compare it to something that has a pH of 4, that's only a difference of 1 on the pH scale. But that substance that has the pH of 3, it is 10 times more acidic than the pH of 4. And then if I wanted to compare something with a pH of 3 to a pH of 5, that's now two spaces I've moved on the pH scale from 3 to 5. So that would be 100 times more acidic. So remember, the lower your pH, the more acidic you are. The higher the pH, the more basic you are. So if you're comparing two different substances with different pHs on the scale, look at how far apart they are. If they're only like one number apart, like 3 and 4, that means the lower number, the pH 3, is 10 times more acidic than the pH of 4. If you're comparing like 3 and 5, those are two spaces apart. So every space is times 10. And so like 3 to 4 would be 10, and then 4 to 5 would be another 10. And if I multiply 10 times 10, that's 100. Okay. And so same thing with bases. If I have a pH of 11 and I compare it to a pH of 10, so remember the base is the higher is more basic. So a pH of 11 compared to a pH of 10 is going to be 10 times more basic. Okay. So how do we do the problems like this? This is what they're going to look like. They're going to ask you, what is the pH of a solution in which the concentration of hydrogen ions is, and they're going to give you a molarity. Okay, so this is molarity, like concentration from our previous unit with solutions. And so they have told us the hydrogen ion concentration is 0.001 molar. So all you have to do is take the negative log of that. So in your calculator, you would type negative. Be careful if you have your own like scientific calculator. Some of them have a specific negative sign button and you don't use the subtraction button. So depending on what calculator you use, make sure you're doing that correct. On this one online from Google, you just use the subtraction button. But negative, and then you would type the log button, and then after that, you're going to type in your concentration. So this one was 0.001, and then when you hit enter, it will give you the answer. So on this one, if I do, I'm just going to use my phone calculator. which if you guys don't know, if you have, I'm not sure about Android, I'm sure Android does this too, but if you have an iPhone, if you turn it sideways, it turns into a scientific calculator, and it has the log button right here. It's log, and then it has a little number 10 down by it. So I'm going to type negative log, let's see, what is it, 0.001. And my answer is, I get 3. So I'm going to type 3 in here. Let's check it. And that is correct. Okay. And so it tells me the answer is 3. So you guys, we're going to look at a couple more practice ones. Oops, sorry guys, I hit the wrong button. And then you guys have something that you're going to practice doing on your own. Okay. So this one, another, again, pretty straightforward. What's the pH of the solution that has a hydrogen ion concentration of, and then here is the molarity or the concentration they give us. So this is my hydrogen ion concentration. Again, in your calculator, you do negative log and you type in this number, okay, 0.00024. And then you want to make sure around the answer on this one, usually pHs, we usually do them to 2 decimal places, okay, like to the 100th place. So on this one, you can type and check it, and then it comes out to this, but because there's a 9 behind the 1, we're going to round it up to 3.62. Okay, so don't forget rounding rules, kind of basic math stuff. Sometimes instead of telling you the concentration of the hydrogen ions, they might just tell you the concentration of the acid. And so it's like this one says, determine the pH of the solution of hydrochloric acid with a concentration of this molarity. So for our class, we're only going to be worrying about strong acids and bases, okay? Because strong acids and bases we know fully dissociate. So however many molecules of HCl there are equal numbers of hydrogen ions. So because these are equal, I can assume that the concentration of HCl is going to produce the same concentration of hydrogen ions. So I'm just going to use that number they give us. Now with weak acids and bases, that's different because they don't fully dissociate, and they have like more complicated calculations. That's something that like my IB class, we learn how to do that because that's a higher level, more complicated calculation. In our class though, we're just going to be doing straightforward strong acid calculations and base calculations. So you would do pretty much the same setup. Here's my concentration, negative log of that, and you can check it, okay? And then you have some more practice ones here that you can practice and check yourself. Okay, they're all going to be strong ones or just the hydrogen ion concentration. The second part is, if you remember from back at the beginning when we talked about strong and weak acids and bases, water itself, H2O, it can dissociate into ions even if it's a very, very low extent. Okay, and so because water can do this, any aqueous solution always contains both hydroxide and hydrogen ions. And remember, hydrogen sometimes we represent as this H3O plus because it's like a hydrogen ion joined with a water molecule in the solution. Okay. And so we call this the ion product constant. And so when I multiply the concentrations of hydrogen and hydroxide ions, I always get the same number. I always get 1 times 10 to the negative 14. So we can use the fact that these two things always multiply and equal this number to calculate pH if we're given the hydroxide ion concentration. It's just it's just one extra step compared to what we were doing. So if you're given a hydroxide ion concentration, what you'll do is you'll use this equation right here, but you'll rearrange it so that it looks like this. Okay, because we need to find the hydrogen ion concentration because that's the number that we need to plug in to calculate pH from our first equation. So what you'll do if you're given a base, or if you're told that you have a hydroxide ion concentration from a base, you will use this first, and you'll do 1 times 10 to the negative 14 divided by your whatever concentration they give you for hydroxide ion. That answer will be the hydrogen ion. Once you get that, then you take your answer and you plug it in to our negative log equation to calculate the pH. Okay, so it's just that one little extra step of calculating the hydrogen ion concentration first, and then you can plug it into the calculation to do pH. Okay. So what would that look like on an example? So this one, it says, what's the pH of a lithium hydroxide solution that has a hydroxide ion concentration of, and here's my concentration. So what you want to be careful of is that they said hydroxide ion, and the formula they've given us is a base. I can see that it has OH in it. okay? So what will happen to some of you guys if you don't read carefully enough, you're just going to do the negative log of this number because you're going to think, oh, it's hydrogen ion concentration, so I just need to do negative log of that. But you got to read carefully because this is not hydrogen. This is hydroxide ion because this formula is a base with OH in it. So what you'll have to do first is exactly what we said. You'll have to calculate the hydrogen ion concentration by dividing 1 times 10 to the negative 14 by that number we were given for the concentration of hydroxide ions. And that would give us the hydrogen ion concentration comes out to be 1 times 10 to the negative 11th. Now that I have that number, now I can do the negative log of that 1 times 10 to the negative 11, okay? And you should get your answer. And one thing to watch out for, guys, lithium hydroxide, that's on our list of strong bases. So the pH should be pretty high. It should be a lot higher than 7 because it's a strong base. So keep that in mind when you're doing these calculations. If you have strong bases or strong acids, remember their numbers are going to be pretty high or pretty low, depending on if it's the base or the acid. And so, keep in mind that if you have a base, the pH should be higher than 7. If you have an acid, the pH should be lower than 7. And so if you get a number that doesn't make sense, you might want to check your calculations again. So this one, again, another example, this one says determine the pH of the solution of sodium hydroxide with the concentration of 0.0033 molar. Now, again, you have to read carefully. This is tricky. They want us to calculate pH, but they did not give us a base. They gave us sodium hydroxide. I'm sorry, they did not give us an acid. They gave us sodium hydroxide, which is a base, okay? So if they give you the base and they ask for pH, that's going to be 2 steps to calculate the pH. You're first going to get the hydrogen ion concentration by using that ion product constant of water. So 1 times 10 to the negative 14 divided by the concentration they gave us for hydroxide. And that will give me the hydrogen ion concentration, okay? And then you can use that answer and do the negative log of it, and you can go through and kind of check yourself on here, okay? And again, this is a strong base, so your answer, if you want to think about it logically, your answer should be higher than 7, okay? Then here at the end, you have a few practice questions where you're calculating the pH from hydroxide ion. So all of these are going to be kind of those 2-step problems, all right? That's pretty much it. When you get to the last page, again, make sure that you've got everything completed and that you submit your report. So if you need to go back and redo anything, you can go redo it before you hit submit report. And then that is it for today's assignment. As I said, the test for Friday is already posted. If you want to get ahead and work on that, you're free to do that. And then once you're done with the test, if you want to go ahead and start working on your review, you can do that. If you need to do any of these for redemption, you can be working on that all next week. This is what you guys are going to get to work on. So if you have to do redemption, you'll have time to do that. If you're don't really need to do redemption, you just need to maybe practice and review for the final, then you can work on whichever of these reviews that you need to work on. Okay. Does anybody have questions for today?